Hey everybody in YouTube land. I have decided to make a couple of video series. I'm hoping that this will interest some other people out there that might be willing to do something along these lines. Maybe not, but it'll be pretty much a documented thing for what I'm doing. So, and that's basically this. There's two projects I have in mind, and they are going to be used side to side together. This is going to be used in the second project, but I don't want to talk about the second project just yet. But I do want to talk about the first one. Okay, so I came up with some random ideas, and um, I thought it would be cool because I've gotten into the Raspberry Pi scene a little bit, and I thought it would be cool to do something with a Raspberry Pi. So, as you can see on my table, I got a bunch of different parts here, but they all come together at some point, and that is this. I want to make a media player for my stereo, um, and I want this media player to be, modern, so I can get online and listen to internet radio, or I can go through my music library, etc., etc. But at the same time, it's retro, so it's going to have, a vacuum fluorescent display, you know, in it, and at the same time runs Raspberry Pi. So I know that we've got RetroPi out there for gaming communities, running emulators and stuff like that, but what about RetroModernPi media player? So that's what I want to call this thing. And basically, what it is, it's a modern media player, but it's in a vintage retro style. And what I mean by that is it's going to be in one of these old 80s, 90s cases. Here's the faceplate, and I've already taken the liberty of doing this. This video is going to be multiple parts. This first part is just an overview of the project and the parts I'm going to be using as far as the engineering is concerned. And then the second part will be the actual engineering, of laying out the board and stuff like that. Then there'll be a part on programming and debugging and et cetera, et cetera, et cetera. So this is the first part, and it's basically the overview and the beginnings of the engineering, trying to grasp what all I need to make everything happen. So this was the faceplate of a satellite tracking rotator system, okay, which are obsolete now. It was for the old big dish satellite systems. I had two of those. One was for the elevation, one was for the azimuth. I picked them up at the flea market 12, 13, 14 years ago. The first one you've seen years past if you've watched my videos, and that was when I made that FM pirate transmitter in that one case. If you remember that was the first one. This is the second one I haven't done anything with until now. And what this one is going to be is this is going to be the enclosure for the Pi and all the circuitry and all that stuff. So it took some planning because I wanted to figure out how I laid it out. And the first thing I did was I dremeled out very poorly. I dremeled out the faceplate here. So it used to be a solid piece with a remote sensor and a couple of LED readout digits, but I gutted it and I put this piece of plastic here, which you can see right here. I had a co-worker of mine CNC that out with the machine at work so I can get it to fit in the display. So that will be the cover. And I've already got it glued in place. I took the Dremel tool and roughened up the edges on each side before I put the glue in there. And it's just simple super glue. You can kind of see it down in there. It's all dried up. And it's not load bearing, so it doesn't have to be perfect. It's not like I'm going to rip the thing off. It's just as long as it can handle vibration and flexing and stuff like that, it's fine. It's not going anywhere. So that's the faceplate. So it took me a bit to come up with what I was going to put in here. At first, I was going to use this, but then I decided against that, and I'm going to use that in my second project, which I'll talk about. I might release a video about it earlier. I'm not sure yet, but I think you'll like it, especially if you follow other electronics people's like 12-volt vids or EV blog or Mr. Carlson's lab or something like that. And I'm by no means competing with that. I'm just doing my own little thing here, so I don't care. Anyways, so I decided, okay, I want to put a VU meter in here because I've got so many of these things. And I like this particular version because when I was a kid, this was the one that kind of got me hooked into the glow and use of these displays. Kind of like a fetish. And then, of course, I need something to display the song information and etc., which is what this one's going to be. I got this one years ago from the Noritake website, and this guy was on sale at the time, and I think you can still buy them today. But this is a 24 by 6 with 4-bit grayscale, which is overkill for what I need, but it'll work. So I'm going to try to mount this in there, and then one of these three in here. Notice I have 3 of these out. Okay? Well, there's a very specific reason for that. I wanted to pick the one that was the brightest of the 3, the one that doesn't have as much fade, because let's face it, vacuum fluorescent displays fade, especially when they're used a lot. So I wanted the one with the most emission. And so as I was going through them, notice the ribbon cables, when they put these ribbon cables in the manufacturer, they didn't follow any standards at all. So it's actually reversed from one another. And I learned that mistake because after I wired one up, I decided to wire the second one up the same way I wired the first one. Come to find out it was reversed. So this is what happens when you apply 20 volts to the wrong pins. Oops. So I sacrificed this one to fix that one, which is a shame because this one is the most dim, and that's the one I blew up. But it's also entirely possible that I ruined the VFD display during the process because I wasn't looking at it when it popped. I just remember reaching over here and turning the power on, heard a snap, and I turned it off real quick. So it's possible that these filaments glue red hot. I don't know. And if that's the case, that's why it's faded now, because I've ruined the display. So anyway, I've sacrificed this one because this one had an unfortunate accident. See the white getter? It had an unfortunate accident. It must have slipped and got wedged into something in my box, so it's garbage, unfortunately. But it's just the way it is. So I'm going to change these cables, whichever one I pick, which I think is this one. I'm going to replace that cable with this because these have individual wires and they're easier to work with. So let's go ahead and turn the power on. And it's kind of hard to tell in the camera, but it does not appear which one's brighter than any other one. But you can tell the difference between these two. One's definitely brighter than the other. So let's see the brightest one here. So I have them all soldered in parallel so I can look at them side by side and take a look-see. From the camera's angle, you can't tell which one's brighter than any of the others, but if you were physically looking at it, you could tell this one's a hair brighter than this one. This one doesn't have as much fade, but this one's definitely faded compared to all of them. But notice something right away. These two have peak hold. This one does not. And I double checked the circuit. It does not have the wire. This came from an RSM 215, and they do not have peak hold. These two do. I don't know where these came from. I can't remember, because the RSM 14 has the same tube, but it's a different circuit board. So, yeah, all I got to do to do this is to clear the peak hold registers is grounded. So as soon as you ground it, it will clear the peak hold register. I gotta find ground. Here it is. See? It clears the peak hold register. So as soon as I hit it again, it'll set the registers again. See? And as soon as I clear it, as soon as I ground it, it will clear the register. Just like that. So I'm just going to hook this to a transistor, a pull-down transistor on the Raspberry Pi on one of the GPIO pins, and that will control it. So as far as the Raspberry Pi is concerned, actually there's a couple things before I get to this point. So when I decide to use this display, there's two things I got to keep in mind. One is the voltage level. So these things, I got it set for 18, but I'm going to bump it up to about 20. Yeah, about 20 volts. So it'll kick up the brightness a little bit more, as you can see. So, yeah, I'll kick this up to 20 volts because the display in the cassette deck, as far as the schematic's concerned, is set for that. So we know at 20 volts we have a current of 140 milliamps. That's the filament voltage, which is 2.7. I got it set a little low because it's DC, but it's running 280 milliamps, but it's also in parallel of all three. Same thing here. So that is 3 times what it needs to be, and this also is 3 times what it needs to be. The filament, when I had one hooked up, was between 80 to 100 milliamps. And I think the current draw was, for the B plus, was not even that. It was like 30 to 40 milliamps. I can't remember. But that, because I want to use one of these displays in here, that will become important in the power supply design. So that's the other thing. So Raspberry Pi, I'm going to run a distribution called Volume.io. I'm sure you've probably heard of it, which is basically a full distribution, MPD, Media Player Daemon distribution, which uses REST API or WebSockets. And the reason why is Volume.io has an elaborate web interface that allows you to configure, pick music, set up playlists, listen to music online, which is nice. But it also frees up the phone, so I don't have to have Bluetooth connected all the time. So it frees those resources up. So I don't have to worry about that. At the same time, I have to have a secondary configuration page because the heart of this thing is going to be a dual 20 watt Class D power amplifier circuit, which I'll show you in a second. That Class D power amplifier has got a built-in parametric EQ, which is set up using biquads because it's a DSP. So I think what I want to do is I want to go from Raspberry Pi to a line level DAC, and that line level DAC is going to be fixed output that'll be tuned to the VU meter to keep things accurate as best as I can, although accuracy is not really much of a concern here. It's more for show than anything. So you'll have that, and then that line level output will go into a circuit board, which will have a op-amp buffer. The buffer will go to the RCA jacks on the output of the amplifier, or on the output of this thing. There'll be RCA jacks back here, and it'll go out to the stereo. At the same time, it will also go into the Class D amplifier, and then it'll also go into another buffer with gain to drive this. Okay, so the cool thing about that is that will isolate the DAC from all the other outputs. Downside is that complicates the power supply because that means I need a positive negative rail to run the op amps, because I want to do split rail because I want to work around 0 volts. I don't want, offset. So that's that. Also, I think I'm going to use, since the amplifier requires 24 volts, I need a 24 volt power supply But then I've got 24 volt to 5 volt DC step down, which will run the Raspberry Pi. Okay, but I also want the Raspberry Pi to be able to go in a standby. So, for example, I have these 3 buttons here. These are probably going to be volume up, down for the power amplifier, and this is going to be power. Okay, so when I press and power this button, or press this button and hold it, it'll power off. Maybe tap it once to mute, press and hold to shut down. And the way the shutdown is going to work is I'll have a high side load switch, which I'll go through all these parts in a minute. I'll have a high side load switch to switch off the load to the Raspberry Pi, and I'll program the Raspberry Pi's device tree overlay so when the Raspberry Pi goes into standby or shutdown, it toggles a GPIO pin. Well, that GPIO pin will go off to the load switch and it'll cut off the power supply. Okay, it'll go to the load switch. Most likely a latch or along those lines, or a microcontroller or something like that. And then when you press the power button, it'll turn the load switch back on, which will power all this stuff up, and it'll boot the Pi again. So let's get that out of the way for now, and then we need to talk about this right here. So this is the base unit. All this stuff's got to come out. The front faceplate goes on here because there's the 4 screw holes there, and there's the 4 screw holes there. So this guy goes like that. So I think what I want to have to do is I want to have to cut off those clips because they're going to get in the way, and I want to use those 4 screw posts to mount that stuff in here somehow. But anyways, so this stuff here is going to go bye-bye. The back piece of it, I want to peel it off and redo it for power input, RCA, Ethernet, all that stuff. So this is going to go bye-bye. I think I'm going to put the Raspberry Pi to get rid of these standoffs, maybe move them around a little bit. And I want to put the Raspberry Pi over here. And then I want to put the circuit board I have to design, which I'll make a video on. It'll be in another part. But I need to make a circuit board that goes here. And that will have the DC-DC converters, the op-amp circuitry, the standby microcontroller, everything necessary to make this thing function outside the Raspberry Pi. Plus, I need to put the audio power amplifier circuit in here somewhere too. So, yep, this transformer and all that stuff, I don't know what the voltage output is on it, but it's not going to work for what I need, so it's got to go. And on the back of this thing is nothing too important, but one of these will be the DC in. Some of this stuff will be removed. I'll probably remove this, make this my speaker jack, my left and right audio. This will probably be the RCA level out, or maybe even if it's a big enough hole, I can probably put my RJ45 jack here. And then perfect, I have these holes, these little plugs that pop out right in here for F connectors. I can repurpose those for my Wi-Fi antenna or USB. So I'm going to have to make holes back here. So I want to use this one for my speakers. Maybe this one either for the RJ45 or USB. I'm not sure yet, because I want to be able to plug a thumb drive in here and use local media or a hard drive or something. And then the Wi-Fi antenna's here. And then this will be power, and that'll be something else. Maybe that'll be the USB. I don't know yet. But I'll figure that out later when I get to that point. So now it's time to pop on the computer and show the parts I'm going to probably use. So basically, since I'm using the vacuum fluorescent display VU meter, it needs a couple of different voltages. So this chip here would work perfectly fine for that 1 meter because it's got the power amp to drive the filaments, because it needs AC voltage to prevent fade going across. And then using this diode multiplier, it will generate around 18 to 20 volts, roughly what I need. Now it's only rated for 35 milliamps for 18 volts, so it may work. We'll have to play that one by ear. So that this uses an external clock, but I think I can use. Again, it's a 5-volt circuit, so it works good there. But I can probably just build this self oscillator here, and everything will work fine. It'll run on its own. And this could be on the high side switch. There's only one problem. This chip is an LM9022, and that LM9022 has been long since discontinued. However, what they don't tell you is that it's the exact same die, chip die, as this guy right here, the LM4871. Let's see. See that? Look familiar? It's the exact same circuit, exact same amplifier. So, excuse me, I can use this chip in the same circuit. I can still get these. They're still in production, and they have a bottom heat dissipation pad that says right here. So that takes care of the design of the vacuum fluorescent display. The Noritake display has its own support circuitry, and it can use the UART that's built in, and we're good there. So that's part one. This chip here is the high side switch, and again, the internet sucks, so it takes forever to load. This guy should work perfectly fine. It even has a dissipation pad here. This should work perfectly fine for switching on and off the Raspberry Pi, plus the output will go to this chip that turns on and off the VU meter. It'll also turn on and off the Noritake display. Everything will be hooked into this 5 volts. Except for the dual rail. This is the dual rail, and I think for an op amp I can get away with 9 volts. It's got 18 to 36 in, so it'll do the 24 volts, and it's got plus minus 9 volt out. So this will work fine for doing the dual rails for the power supply on the op amp circuitry. So, and it also even has a control pin, so we can turn the power on and off, and it's good for 5 to 12 volts. So I can take my 24 volts and put it here, which is hot all the time, and I can run this circuit straight to the switched 5 volts. So as soon as that high side switch goes dead, so does that. So we lose that as well. So at that point, everything is shut down. The only thing I need to do is I have to have a 5 volt standby, which is no problem because, again, my next in line here is this is my 5 volt DC-DC converter, and it's rated for 3 amps, which should be plenty. The Raspberry Pi needs 3 amps by itself under full load, but it's not going to be fully loaded. It might need 2 amps max, which leaves an amp to mess around with on this and some other things. So this will be the 5 volt circuit, and this will run all the time, and its output will go into that high side load switch, which will cut the power off and everything else. But since that's hot all the time, that will go to the standby microcontroller, which when I start placing the circuit together, I will get to that point. So the reason why I need this circuit, as I mentioned before, the filament has to be AC, and that filament supply needs to be AC so that you don't have fade across the display. And plus, having an AC signal gives me the ability to do a step up. Here's another design of one. This is actually from an old patent that's now expired, but this gives a rough idea of how the circuit would work. All this is just a dual push-pull transistor array. So if you look at it from a modern perspective, if you take this guy, move it over here, and then flip it around the 180 degrees, you technically have an H bridge between the filament. This does an inversion process that it turns this one high when this one's low, and then this one low when that one's high. But notice it's got a Zener diode so the filament floats above ground. And that's important because on a vacuum fluorescent display, this filament is your cathode. That's your emissive material. And that cathode has to float above ground so that when this grid, because those vacuum fluorescent displays, if you probably noticed it earlier in the video that some of the segments were ghosting on. Well, that's because you need to be able to drive the inactive elements into cutoff. And cutoff is below the potential of that filament. So if this filament is at 0 volts and the grid's at 0 volts, you're not really in cutoff. But if you drive this filament to, say, 3 volts above ground and this guy's 0 volts, technically this is negative 3 volts in respect to filament. Okay? So if I put the meter to the cathode, just like any vacuum tube equipment, if I put the meter at the cathode and put the other probe at the grid, it's going to be negative 3 volts when it's off. So that's why it has to float above ground. So it will turn off it'll turn off the grids into hard cutoffs so they don't ghost. So you don't have a ghosting problem. So that's the circuitry. That's basically everything I'm going to use in the design, except for this last piece, which is right here. This is an evaluation kit of the power amplifier I'm going to use, and this is a IS31AP2111 blah 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 blah. You can pause the video and read that. So what I want to do is I want to pull up the data sheet for that so you can see what it's actually. See, evaluation board. So this is what the board actually looks like. And the cool thing about it is it has I² bus control for the hardware that's on board. So I can control this chip. I can set the treble. I can set the bass. I can set the parametric EQ. I can do all of that from the I² bus. This chip also has, I'll pull up the schematic here. This chip also has its onboard 3.3 volt, 5 volt regulator, so I don't have to worry about that. But also this chip is designed to work with the I²S protocol. The problem with that is the M clock in this chip is required, which is something that the Raspberry Pi does not put out. And that's a problem. I've been through this data sheet and I can't. It's an internal PLL that has to be locked to the M clock. I can't turn it off. It will not work without it. Luckily, sitting right here is a CS5340. That is an analog to digital converter. And by default, this thing's wired up, so it takes analog audio input, so I can have a Raspberry Pi compatible DAC sitting out here, going through a couple of buffer op amps, and then I can drive this directly, and its output and this one does have an M clock, which goes right over here through these jumpers. So that will drive it directly, no problem, through the analog. Which, it might introduce a little noise because I'm going from digital to analog, and analog back to digital. But that's the only way I can get a line level out. Because I need the line level out for RCAs. This chip does not have line level out. So, but it does have the parametric EQ and all that fun stuff. So, I think that's going to just about cover it for this video. Sorry for the long discussion, but this is the beginnings of a nice little project. I hope you're interested. Please leave a comment if you want to continue to follow this project or not. I don't want to make a whole bunch of video if nobody wants to watch it. You know, nobody wants to see the engineering and design process and as this thing comes together. If nobody wants to see that, then I'm not going to make any more videos. But if this is something you want to enjoy, you want to sit back and watch it, then I will continue to produce more of it, and hopefully you learn something from it. Maybe I'll learn something from it. Anyways, thank you for watching, and please feel free to leave a comment if you have one.